Você... Hello. Was machst du?
Hi everyone. Welcome to this new episode of our GraphQL user group in Zurich. This time we have a bit more technical problems in the setup in the beginning because we were setting up a way for our remote speaker, our first speaker we have here, Tim, and also a way to stream out at the same time. Okay, so we figured that out and finally we get this thing to work. Okay, let me tell you a bit about the GraphQL Zurich user group. So we want to bring people together in the Zurich area to talk about GraphQL, to chat about what is new in GraphQL and help people from different companies to really share knowledge about how they approached GraphQL in their company and what challenges they had and so forth. And also we want to keep track on what's going on in the GraphQL ecosystem. Bring in new speakers like, for instance, Tim today from Germany to talk about new stuff. So how does it work? Every meetup we are doing has 3 talks. Each talk is 25 minutes plus 5-minute Q&A. And each talk is done by a different person from a different company, so that we have different storytellers. And we want you to also engage with us. So if you want to speak at the GraphQL Zurich user group, please get in touch with us. Or you want to host one of our events, reach out to one of the people that are there today at FelFel and talk to them that you want to host something or that you want to speak at our GraphQL user group. Also, one important aspect here, if you have never done public speaking before, just reach out to us. We can even help you get the talk structured and get out there. Okay, with that, let's talk about the next event before we talk about the event that we're doing today, because next time is in April on the 26th and we will be at Smartiv, and there we also have some cool speakers. There will be Lauren from the guild speaking at that event, and we also have other speakers there, so make sure to sign up for the April event. For this event we are at FelFel in Zurich. It's just a couple of meters from our last event. So essentially, if you had been at Swiss Life, it was just a couple more meters to get into FelFel. Thanks to FelFel for hosting this event. And with that, we are almost done. The next speaker, or our first speaker today, is Tim. And Tim is very well known in the GraphQL ecosystem. He worked for Prisma and he also founded Stellate, or if you know it more under the name of GraphCDN, they transformed into Stellate, and he will talk about managing GraphQL load to your GraphQL APIs. After that, we will have a FelFelian, or I don't know how we call them, and that is Behrooz. And he will be talking about the learnings that they had when they started with GraphQL in their company. So I'm looking forward to that. And last but not least, there will be Pascal, who will talk about the true potential of data loaders. So let's get started. And let me get Tim on screen here. Hi, Tim.
Hi, Michael. Good evening.
Yes, sorry for the initial interruptions, but we had to figure out how to set that really up. But now it works. So
All good.
the stage is yours. You can share your screen and then I can put it on here.
Okay. By the way, hearing myself.
Yes, give me a second.
That's okay. Okay, I'm ready. Let me know when I can start.
Okay, so I take myself off the stream and then you can go.
Okay. Good evening, GraphQL Zurich. It's a pleasure to talk to all of you, and it's a bummer that I can't be there in person, but I'm sure that we will still have a great time. I'm Tim, and co-founder and CTO of Stellate, and we're doing GraphQL edge caching, building GraphQL tools at the edge, starting with edge caching. Today, I want to talk about how you can protect the load that comes to your GraphQL API at the edge. Now, why would you even care? What's the problem here? Why do we want to protect the load? A bunch of reasons. So I just named the top 3 that I'm aware of, but I'm sure there are way more than that. There's a popular GraphQL client out there which has a GitHub label in their repository, which is just called infinite loop and infinite. And so it turns out that there is a very common case that even the libraries have sometimes an issue that they bombard a GraphQL server just by a mistake in the library, not even talking about user land, library land, so that this is even a label on its own in such a library. I want to talk about a quick story here. A couple of years ago, I was maintaining a GraphQL API in production. The API was backing a VS Code extension, and we had a bug in the VS Code extension. In that case, it was in user land, and we had an infinite loop running. And so VS Code extensions obviously deployed to multiple machines, and we were basically DDoSing ourselves. We had a couple of billion requests at the end of the month, so that's a real thing. Scraping is a topic. So if your GraphQL API exposes some valuable data, so one of our customers, for example, has a sports API, and apparently the competition is interested in scraping that because it's valuable data, then that is something you might want to protect against. And then even if you are intending to allow people to access your API, aka a public API, then you can be sure if you give a developer a tool, they will do weird things with it, and at some point also hit the limit. So some of the biggest reasons why you want to protect the load of your GraphQL API. And I will actually come with a hot take here. I even believe that most of the GraphQL APIs out there, you could take down with just a couple of lines of code. It's my opinion. I haven't tried all of them, but usually the protection is rather simple, and you don't need a sophisticated method to put so much significant load on an API that it's not able to deal with it anymore. So we're talking about APIs. Now the question is, how much can we learn from REST? Are we basically done here and we just apply the same methods that we apply to REST APIs to GraphQL? Yes, that's actually it. Thanks everyone for listening. That's my talk. No, that's of course not the case. It's a bit more complicated than that. Why is that? So if you have a GraphQL query can be very deep. You might request a lot of items. So for example, in this query, it would be up to 1,000 entities that we would get back from the backend. Now, that wouldn't necessarily be 1,000 REST calls, but many, depending on how you request. So with REST, you have more predictability on what comes back. In this case, it's quite hard. You can't just look at the HTTP level. That's not sufficient anymore for GraphQL. GraphQL is a new technology, and that new technology also needs new tooling. And so what is really the atomic unit here by which we limit? What are we looking at really? So far, we're aware that in the API ecosystem, what's very common is looking at an HTTP request, right? So CDNs and services out there, they look at one HTTP request and they say, maybe I allow 1,000 per hour. That is a good start, even for GraphQL, because GraphQL is still usually running over HTTP. However, it's usually not sufficient. And that's because, again, one GraphQL query could go very deep. One way to tackle that is by going with persisted operations, also known as persisted queries. That's an approach that Facebook is famous for. So Facebook basically turns every GraphQL operation that some of the clients are sending from the browser, from the mobile clients, they turn that into a mini endpoint, basically. And so for each endpoint, they're now looking at the traffic and they're looking at how can we control the load here. So that means more traditional methods, such as we have for REST, do apply again. However, this is something that is hard to introduce in hindsight. If you, for example, already have mobile clients out there, it will be a bit tough to introduce that. Something that is a bit more approachable, easier to use in the beginning is if you pass the query and you look into how many query fields, mutation fields are we sending here, how often is, for example, the add to cart mutation part of this. And then last but not least, based on complexity score. So you're basically taking the query and you try to guess how costly would it be to run that query. That is something GitHub, Shopify have been popularizing. In that case, also simply because they don't control all the queries, right? So option number 2, persisted queries wouldn't work for them. If you have arbitrary GraphQL queries coming against your API, you will need to have a more generic solution. So that's where complexity scores come in. I won't talk about limiting by HTTP request. I will also not talk about persisted operations. They're a little bit more custom, but really the query and mutation fields and the complexity score, those two, I want to dive into a bit, double click on them. So having a look at the operation count, or really the top level fields here, again, we can have an example where we say our rule is we only allow 3 requests per second, and then we would reject any further requests, or would block them or do something with them. What we would do with them, I will also dive into that in a bit. There are a bunch of options. However, if we are now limiting, if we want to say the add to cart mutation, I don't want people to call that too often. I don't want my backend to be overloaded. I don't have that capability, that fine-grained capability on an HTTP level. That's why we want to look into the GraphQL request actually coming in. And in this case, we can parse it and say, hey, I'm only allowing 1 add to cart mutation per second. So this mutation is not allowed here. Now, the other option, which is the problem with this, it's not very accurate. We don't know how deep do these queries go. And for mutation, it works well, but for queries, it's not very accurate. And so the solution for that are going by a complexity score. Complexity score basically is a cost score. You're parsing the query as it is, and you guess by how the query looks like, how expensive the query is. And so in this case, we're saying, again, we allow 3 requests. They could be arbitrary deep, but here, if we go by score, in that case, we can now detect that request might be too heavy for our backend, and we want to reject it. And so let's have a quick look at how this complexity score can work. I want to call out that there is not the one implementation. There's not the one standard. I would wish that the ecosystem finds an agreement there. I will give one example of a simple algorithm now here, and then we will highlight a more complex but complete algorithm afterwards. So in this complexity algorithm here, you would give every single scalar field the 1 point. You would say if it's nested and we have a singular relation, for example, with author, we'd add 2 points. So this whole author section here gets 4 points for the algorithm. ID text completed, or 1 point. And so in total, we have 9 points for this section here. And then we would say as limit is 2. So we're receiving 2 items. We're multiplying by 2. Few things I want to say here. If you go this journey, and we will later look into more practical ways of actually implementing this. If you go this journey, then you will need to have this synced to your pagination schema layout. So if you do not use the relay spec or use limit, you use first, you will need to teach that basically to your complexity algorithm. Take that into account. This is a rather simplified algorithm. There is a more elaborate one developed by IBM. This one also takes into account that each field might have a different weight. So for example, if I'm running a full text search, I have a search field that might need way more compute than if I'm just receiving a simple, let's say, int 32, all right? So this is another option, interesting paper, recommend having a look. Great, so that's the start, and those are basically the atomic units here that we can go by again. We can go by the HTTP request. Persisted queries can go by specific fields here. Query fields, we can count them. We can say I'm only allowing add to cart like 10 times per minute, for example, and we can go by complexity score / cost function. So that's basically how we now track incoming requests, or the atomic units really that we are limiting by. The question is, what do we do once we want to limit? There are a bunch of options actually. Most famous option, probably the 429, right? It's a HTTP status code for a good reason. This is the most common option because also the easiest to implement. So if you just say, I want to block this request, you don't need to, have any other state. It's the easiest to implement, and that's the most common that we see. So more referred to as rate limiting. The other option is, instead of rate limiting, you can also slow things down. You can say, I don't want like a certain amount of requests to be reached. I don't want anything more than that. Then you would slow the request down, and potentially it would be a timeout. Usually you would implement that with a queue. And then there's a more advanced use case. So for example, for Facebook, if you have a malicious actor who really wants to do harm, they might want to scrape everything, do a lot of things on the platform, bunch of things that could happen. So in that case, you want to not tell them that you're in defense mode. You want to pretend as everything is fine, and you would just send back garbage or like fake data. That is really, if you get into that territory, that's more a cat and mouse game. And then again, the attacker will see, what can I do now? We will not go into that rabbit hole today. It will become an arms race, and at some point, it's you will probably need AI. We today assume that for most use cases, we can cover them by rejecting certain requests, blocking them, or by slowing them down. So that's a great baseline. So what else can we do to protect our API? I want to talk about one solution that is maybe not very intuitive if you think about protecting load or controlling the load to your API, and that is caching. This is actually one of the main reasons people use Stellate, because if you have a spike, if you have a traffic spike coming and you're able to cache certain requests, that's a way how you can even it out for your actual backend. And so a typical example is we have Black Friday, a bunch of e-commerce shops are using Stellate, and they just don't know what's happening when this extreme like inbound traffic is coming. And usually if you do not have a fully serverless setup, you will need to highly over provision, which is also very costly. Even if you have a serverless setup, that's also not for free. So caching is a great way to deal with that. In our case, caching at the edge. And I also want to say, for some, it really depends on the application how long you can cache. With Stellate, you can do purging, like you can implement a correct purging strategy with which you basically can cache everything for a year. But even if you do not want to spend time on implementing purging, oftentimes a 5-second cache can help a lot. In Stellate's case, by the way, where even if you do 0 seconds cache, we're doing request collapsing, so that is basically a deduplication. So if like 1 million people ask for the same data at the same time, we will wait, we will get that data once and then return it. Yeah? So that is a simple option here to increase the load of your API. I want to talk about one more option. Breathe quickly. So we just had 2 options. We talked about how to limit based on rate limiting, throttling with different atomic units that we can track. Caching is a great option. And last but not least, you can also validate any incoming request, right? The options that we looked at before are rather a way to reduce or to control the throughput over time as a function over time. But also there's a bunch of crap that you don't even want your server to see. So for example, it might not even be a valid GraphQL query or a valid query against your schema. You might have more additional input validation that you want to enforce first before your server even sees it. You can apply a bunch of limits, right, on like the alias count, query size, cost, depth, tokens, etc. And then really apply authentication authorization logic, right? So there are a bunch of things that you can do to really narrow down the amount of requests that would potentially bombard your GraphQL API. And really, this is a way to look at this is the Swiss cheese model. I'm actually just realizing that this is GraphQL Zurich, and so this was not intended to make any fun here of Zurich. I hope you don't take it too serious, but Swiss cheese model really saying that if one of the layers is not catching the issue, the incoming problem, potentially, then we have more layers that we want to apply. Right? So you don't just want to apply rate limiting, you for sure also want to have some validation logic, your authentication authorization. Now, that's great, right? So that is like a pretty full framework on how we can control the load for GraphQL API. The question now is, where does all of this live? Right? That's like this eternal debate. Now, as the edge is becoming more popular, should it all be at the edge? Should it all be in the data center, in the region? And here I just have to agree with Guillermo Rauch, which is that neither of those is probably the answer, but as the edge is getting more powerful, but also the regions with more serverless are getting more powerful, makes sense to really think about where does it make most sense and then put it there instead of going with these extremes. And here's my suggestion. This is not the truth, but this is a trend that I'm seeing where things are coming. So also, where would we want to run this? We want to run this if we look at the request pipeline, we would want to run this as early as possible. The earlier we are blocking requests or controlling them, the less compute we're using, the less cost we have, right? And so that's why, as you can already imagine, I believe a bunch of things should run at the edge. Don't have to run them at the edge. You are also perfectly fine with running it in your region. However, the more you run at the edge, the less your Kubernetes cluster, your gateway, your Lambda function, your database, your logging, all third-party services will even be affected. So really to be able to deal with high load, there's a bunch of stuff we can already do at the edge, despite of the scaling topics, right? Wrote down some scaling topics here for a GraphQL API. Obviously, we know that DataLoader is a great option, making everything serverless, and the planned resolvers that Benji is talking about, that he's currently working on this amazing project. Those are things that we can do for sure, but we're today talking here about the left side. Bias alert, obviously. I founded a company which runs GraphQL tooling at the edge, so take it with a grain of salt, but this is where I'm seeing the industry going. Now, the question is, how can we get started on this? When it comes to persistent operations, there's a nice plugin for Node.js at least. I'm sure Michael will know more about the .NET ecosystem for like the persistent queries, persistent operations, also known as persistent queries. There's a plugin for Node.js as well from the Escape Tech people who, which basically validates, has like the static validation of not allowing a certain amount of depth and query size. And then, shameless plug, we at Stellate actually implemented a rate limiting at the edge solution. And I want to quickly talk about that one actually. So when you want to do rate limiting, GraphQL rate limiting, then you will want a way to measure what's going on, right? You want metrication, you want to have insights, because you want to know, am I blocking someone that I shouldn't block or that I wouldn't want to block? So that's why we built a whole like metrication setup around that. We are using a sliding window approach. You can do basically most of the approaches that I presented throughout the talk, including complexity-based rate limiting. We're supporting. It's all in early preview. So curious to hear what you think when you try it out. But again, this doesn't have to be the option you look for. Obviously, I'm inviting you to try anything out. Now, the question is where are we headed from here as an ecosystem? What's coming next? This is still, although this is pretty basic, you could say, a bunch of these concepts have been around for quite a while. If you saw that the paper was from 2020. This is still not common, like best practice, and there's a lot we need to do as an ecosystem to make that mainstream and best practice, especially for newcomers in the ecosystem. Persistent operations still not mainstream, and also again, if you want to introduce them later, it will be tough. So it's important to look at that early. Complexity-based rate limiting for everyone. This is something that the giant companies like Shopify, GitHub, they have strong solutions there. It's just not something that is mostly available to the ecosystem. That's our goal, to make that easy with Stellate. And then further in the future, what I can see really is that you're basically building up a control loop, a control circuit, where you say, I'm actually taking the real compute from my backend, and I'm feeding that back into my complexity algorithm. So I'm able to block or like limit more accurately. Right now we have an approximation, right? We say there could be up to 1,000 entities coming back, but it might just be 100. And so that is still something I see a lot of potential in. That's it from my side. Now this is the end for real. Thanks for listening.
Hey Tim, that was an awesome talk, and yeah, it's a true problem that people actually face. Like for HotChocolate or for the .NET ecosystem, persistent queries are really built into our GraphQL server, and it's for me it's the easiest way to get it secured. But it's like there's so many examples. Like GitHub is the main example where you really need rate limiting, right? And that's where it gets complicated.
Yes, exactly.
But how do you guys integrate that? Does Stellate also have so you essentially just plug it in, or you have like a GraphQL server that is actually fronting the actual GraphQL server and pass the traffic through that in a GraphQL server, or?
So we basically have a, let's say, simplified or like more minimal GraphQL implementation. It's not a full-blown GraphQL implementation. It's just a minimal parser, actually written in Rust. It's actually the fastest parser out there. We just haven't published it yet. And that is basically just looking and parsing the query, and we have a bunch of state at the edge. There's no solution for that, so we needed to deploy that on our own globally. And so we're basically doing the rate limiting per region then. And so you can decide what kind of buckets do you want. You can say, I want a rate limit by IP. I want a rate limit by a header, by JWT token. You can have custom functions for that. So that's basically a solution. And then you can also do complexity based. And for the complexity based, I also didn't talk about it a lot. You need a way to establish your baseline. That's really the challenge, because you don't know what is a good complexity score, because it's not a score that we grow up with, right? And so that's really where you first need at least some metrics set up, so you can observe the traffic over time, look at it maybe for a day, and then you see, okay, this is maybe only like 1% of my users are sending so much query requests. I want to limit them, and everything else I'm allowing.
So how do you define these extra costs? Like you identify a very expensive field. Would you configure that in the portal, or do you provide that on an SDL file as a directive, or what is the way you would go there?
Currently, we're not yet supporting that.
Okay.
That is not yet a use case we're supporting. Yeah, a bunch of things missing, including, for example, then support for the persistent queries. Right now we see a bunch of people having this use case for public GraphQL APIs, because that's more scary. You have others accessing your API, and that's where we have the complexity-based rate limiting.
Yeah, but anyway, when I saw your announcement that you are doing that, I thought that's brilliant, because like when I teach GraphQL, I always tell people, so the easiest way to go is do persistent queries. But if you cannot do it, then you have to implement query complexity, and that's where it's overwhelming in the beginning. And if you have something that is really fronting your server and you don't have to do anything in your actual server implementation, you just put Stellate in front of it. That's brilliant.
Yep.
Awesome.
That's why we built it.
So I have no more questions from the crowd.
Okay.
So thanks for joining us, and
thanks for having me.
Thank you.
Okay. See ya.
Goodbye there.
Bye.
So I will stop here and Pascal will take over from Zurich. I'm actually in Norway and I just jumped in. That's why I was a bit out of continence in the beginning because I thought actually Pascal will do the introduction today, but we have had technical difficulties, and while they are replugging everything to get Zurich online and to get our online speakers ready, or our in-person speakers at Zurich ready to talk. We have as the next speaker, I think, Behrooz. I'm just wasting a bit of your time so they can get this all plugged up. So that was a great beginning with Tim, and I will leave you to wait a couple of minutes until Zurich gets online. So next talk is Behrooz.
I forgot my notes.
Right, so also for the people on stream, hello from Zurich.
Hello.
We finally made it. Sorry for the technical difficulties from the beginning. The next talk will be done by Behrooz. He's from FelFel. He will introduce himself later on. And I will talk about learning GraphQL the hard way. So the stage is yours, Behrooz. Go.
So thanks everyone for joining. As Pascal introduced me, I'm Behrooz, and with Roma, Lee, Borut, Joao, we are the enterprise team here at FelFel, and Sue is our CTO. And I think Amin was also sitting somewhere. So if you want to reach us and have a chat about FelFel, don't hesitate. And today I'm going to talk about learning GraphQL the hard way, because we started kind of adopting GraphQL in our tech stack around 1.5 years ago, but we did many mistakes. And today I would like to basically give a report on how we managed to, like what were the challenges and how we managed to kind of keep this stack, the GraphQL stack using HotChocolate library somehow under control. And of course, I will start with a made-up graph, which is kind of showing our eagerness to adopt this new piece of technology in our stack over this 1.5 year. And my talk will be about this portion, basically, of the graph, basically all the challenges that we faced and how we recovered from them. And of course, 1.5 years ago, at this point, our code looked like this. Basically, it's a class called query. And we basically used all the attributes that HotChocolate offers for sorting and filtering and everything. And we simply inject a DB context in this resolver, and we just return it. And magically, HotChocolate generates all of the filtering and sorting functionalities. And this was great. I mean, you have to consider that we were coming from this kind of REST kind of background, that every new field had to go through this kind of backend development cycle. So you can imagine when we start implementing our GraphQL backend and we gave so much power to our front-enders, it took maybe like a week until we had this kind of new way of, for example, in this case, fetching product all over our front-end stack. And literally maybe like after 2 or 3 days that we realized, okay, maybe that this is not the best idea because it's just a bit too unpredictable. It was already considered legacy code, like literally from the beginning to the point that we realized, okay, this is legacy, maybe it took like 10 days. And of course, we reached to this point of the graph. I mean, as you can see here, sometimes it even went negative, like we were really thinking about kind of going back to our traditional REST setup. But this is the point that we started thinking about, okay, how can we control this new piece of technology? And the first thing that we did was writing a schema to a file. It's a very simple thing, but the issue that we were facing in the beginning was that we are using the kind of the annotation-based syntax of HotChocolate to create our schema. And you have to consider in this syntax, basically the name of the class is defined to a large extent the payload that you get from the GraphQL. So for example, in this case, we have a mutation. We are using this use mutation convention. And you're doing some stuff, and then we are returning an object of this, an object class. And this kind of like behind the video, but you can see that basically the query that is generated from this class has the name of the class in the payload that we return. And of course, in the beginning, we didn't really understand this kind of the tie between the name of the class and our GraphQL schema. So it happened very often that we were just changing something randomly. Of course, this code will compile and there's no compilation time issue, but it meant that our GraphQL schema changed in a kind of an unpredictable way. At the time, as I said, we didn't really understand how this thing works. And that's why we started kind of, as I said, thinking about how to control this thing. And the first thing that we did, it's a very simple piece of code that I recommend everybody who's using HotChocolate to add to their program.cs file, which is basically you are getting your request executor, and then you have access to the schema object that is generated at runtime, and then you can simply just write it to a file. And this is great because when we are looking, for example, when we are sending a PR or when we are looking into our commit log, then issues like similar to what I showed before, it's easily detectable. I mean, now it's a bit behind, but here you can see that we can easily see that, okay, the name of this record has changed, and we could see behind this that the name of or like basically the structure of our payload has changed too. And actually, this is a very kind of a simple but kind of powerful kind of pattern and approach. And we actually took some extra steps. We also used the same schema object to create some reports. This kind of a new thing. So basically, as I said, we have this class which is called GraphQL Schema Report Builder, and we're just passing the schema to it. And again, conf is behind this screen, but you can see that, for example, in our case, we are naming our authorization policies kind of after our GraphQL query. And in this case, we can easily see that, for example, some of the authorization policies are not named correctly because we have access, as I said, to the schema object. We can compare these two strings very simply. And we can basically make a report of, for example, which operation they don't have next. They don't have authorization. And as I said, for example, in this case, you can see that we have a query called product by IDs, but the authorization kind of attribute that we assigned doesn't have the S. And that's kind of these kind of mistakes are being caught when we are generating our schema. And this was already kind of a huge step for us because we managed to at least control our schema generation. And that's why we pushed a bit further this whole idea of observability. And we start looking into OpenTelemetry. Because something that you have to consider is that HotChocolate actually offers a very rich set of instrumentation for tracing. And basically what we did is that we just watched one of these Michael's videos, one of his conferences, and we just did basically everything that he was showing in that talk. So basically you just add instrumentation to your GraphQL server, and then you can also kind of modify the traces that you gather from your GraphQL application by injecting an activity enricher kind of service. And for example, in this case, you can see that we are kind of naming the trace after the operation. And in our case, actually, we are using Azure App Insight, which has an exporter for OpenTelemetry. And we start sending all of these traces, which was kind of a huge step for us to basically understand how HotChocolate works a bit better. And it looks like this. This is a screenshot from our App Insight. And this specific operation was very interesting for us because from the beginning of kind of start working with HotChocolate and GraphQL, the assumption was that all of the queries run in parallel. Like that was a part of the deal. And then a few months later that we add all of this OpenTelemetry, suddenly we realized that, okay, one of our actually queries that shows, it's like a periodic kind of query that we run to show the consumption at our FelFel fridges. it kind of runs in this pattern, which looks beautiful, but it basically it shows that this query was being executed in a serial way, not in a parallel way. And of course, it led to a lot of timeout issue because we had like few queries that they were running a bit longer. And this meant if we were running it in parallel, it wouldn't cause any timeout. But because we were running it in serial, we were hitting the HTTP kind of timeout. And as I said, this was very important because we realized it after adding OpenTelemetry. And I mean, this specific case actually turned out to be about the way that we are querying from database. I don't know if you already realized it, but here this toList call is basically a blocking call. It will block the thread, which meant that the work scheduler of HotChocolate couldn't really continue with other tasks that they were supposed to run in parallel. And we simply changed it to the async version, blah, 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 something async, and then you pass the cancellation token. The same thing is just at the end is toList async. And after this simple change, it basically looks like this. So now you can see that everything runs in parallel, and the execution time of this query was a fraction of what we observed before, which was a huge improvement for us. But this kind of triggered also our curiosity to look a bit deeper into the execution, the execution plan of the execution pattern of HotChocolate. And this was kind of like the beginning of really looking deep into data loaders and kind of understanding the execution plan, as I mentioned. And this kind of like a bit of a hidden feature. I wished Michael would put it a bit kind of like somewhere a bit more visible in the HotChocolate documentation. We kind of found about it a bit later. But basically, by sending this GraphQL query plan header, HotChocolate will append the execution plan to your GraphQL request. So for example, in this case, you can see that we have a query with two different kind of fields. And you can see here that it says the strategy is parallel. And if we try the same thing for mutation, it will say sequence. But my point is that this was kind of like the beginning of us looking into DataLoader. And the DataLoader topic itself for us was also a bit of a black box because, of course, I mean, like usually when they talk about DataLoader, they keep talking about this N+1 issue. But what we realized is that, yes, of course, the final artifact, the final kind of result that we are, the final result of using DataLoader is to solve this N+1 issue. But I think the better way to explain DataLoader is to really talk about how data loaders are being executed and how do they traverse in your, how basically HotChocolate traverse your query request. And this is maybe is the closest thing that I found to the description. It's from the Facebook page, Facebook GitHub kind of page about data loaders. And you can see it's very technical. It's very difficult to understand. Now I kind of understand it, but definitely if you were showing me this sentence like 1 year ago, I wouldn't understand any word here. And that's why I thought maybe it's a good idea in this talk to also talk a bit about the data loader execution. And I started making an example, but then this morning I thought, okay, you know what? I'm just gonna make a demo because it's a talk, so it's always good to have like a demo, and of course hopefully things are not gonna go wrong. So this is basically a simple kind of like a toy web application that I just made this morning to show how like using a data loader, all the fields are being batched together. And basically the idea here is that we have this set of documents that they are connected to each other. Basically each document has a top, right, left, bottom kind of connected document. And you can basically start writing your, can I go here? Yep. You can basically start writing a GraphQL query, and it will basically start showing how this will look like in the like basically it will represent your selection in this grid. So for example, in this case, you can see that there's this top level node. So if using kind of the data loaders, first it will select this node, and then it will go one layer deeper, which means that it will select the left node. But now here, if I add a right node, exactly, you can see that the second layer, they are being batched together. And this is basically the whole concept behind this data loader. Basically, it will traverse the tree, and whenever it sees a data loader, it will try to batch all of the requests together. And I will publish this page. I think you can play with it. I mean, you have like some more interesting examples. So for example, here, also you can click to see each step, basically what happens. And then, for example, in this case, you can see that the our selection tree is complete. So we selected all the fields. Or you can kind of have more complex examples that you can just write your kind of GraphQL query. It will give you this kind of graphical representation. And then you can click here to see each one of these execution frames, so-called, kind of by using DataLoader. So for example, in this case, you can see first it will select the nodes because they can be parallel and they can be batched together. Then in the next step, it will select the next nodes. Then we have a batch of 3 items. And you can see in 5 steps, basically, we can fetch all the, all of this. I don't know, there are like 10, 12, basically, document. Yeah, so that was the demo. Thank you. And if I can go back to my presentation. Yeah, exactly. So this was kind of the boring version. And then I made a web app out of it. But again, I talked about DataLoader. I think the challenge that we have right now, first is that we are using HotChocolate 12. I believe that in HotChocolate 13, there is a new kind of syntax, a new approach that's a bit shorter. But I mean, as I mentioned in this, and as you saw in this like previous graph, DataLoader and all of this like HotChocolate stuff is really about like trying to resolve your query in a parallel manner, which means that all of the dependency injections are much more complex. So that's actually one of the things that we are now kind of struggling with to kind of like find what is the best way to safely inject services in HotChocolate. And also we have an issue with the very long names. We really have like names that they are, I don't know, like 100 characters because it's like, I don't know, menu of product, in location, by date, delivery. Like this is literally a name of a file. And that's basically one of the main things that, one of the main challenges that we are dealing with right now. And at this point in the history of us, kind of adopting GraphQL, it was up to this point was very challenging. At this point, we are still looking into kind of architectural, like more architectural kind of decisions and how we can, like the shape of our schema. Like, because at this point it was a stable, we could really look into the shape of the schema. And it was around the same time that we are still looking into basically the Apollo caching technology. And yeah, I mean, it was around the same time that we actually realized, okay, like up to this point, we didn't really know much about GraphQL. That's kind of like, that was the time that the fun part started. And that's why, kind of from the architectural point of view, we decided that we want to separate the GraphQL layer like completely, kind of like to make it completely independent from our domain layer. And we realized that it's a much better approach to avoid this annotation kind of syntax and move more towards this kind of explicit binding. This is what we are doing right now. I don't know if there is any suggestion to improve it any further, but here basically it's much easier and much safer. Basically, we have control over what are the fields that we are kind of exposing to the end user. And as I said, kind of the current structure that we have right now is basically this three-layer structure. In the middle is our domain objects. They are somehow, I would like to think about them as the in-memory representation of our data. And then we have a very explicit kind of database layer and a very explicit GraphQL layer. So on our database layer, we are explicitly mapping to our domain objects. And in our GraphQL, we are also explicitly mapping from domain to the GraphQL schema. Which brings us to this point. Basically, that's where we are standing right now in this made-up graph. As you can see, it has a positive slope, which means that it's all good and like we are safe and everything. We had like few kind of ups and downs here, but now it's stable and we are very optimistic about what's coming next. And this is a screenshot that I literally made like 5 minutes ago or 20 minutes ago before starting. Our GraphQL setup at the moment is not that big. I mean, this is 26,000 requests during 12 hours. Is really not that many requests, but we are kind of rapidly, as I said, adding GraphQL client to all of our front ends and IoT devices in the field. And that's why kind of up to this point, as I said, like that was kind of like current situation. But in future, we are really kind of, these are the immediate topics that we are interested in. The first one is the persistent query, especially around rate limiting. We think we can like that. We believe that actually is one of the approaches that we can take for rate limiting. Caching is also, you have to consider that we have IoT devices in the field, and kind of to save network for us is very important. GraphQL already helps by basically fetching exactly the fields that we need, but we believe that we need to have in near future, we need to push it further and introduce caching. Subscription also is one of the things that we are very interested right now. We have like 4 different kind of services that we are using for this pub/sub kind of use cases, but we believe that we can migrate a lot of them to subscription. And the service injection, as I said, right now we are kind of like trying, like running it a few times to see if, but I believe that there's a lot of kind of improvement that we can do also in this area. And that is pretty much it. Thank you very much for your time.
Right, so awesome talk, Behrooz. Now we are open for questions. So if anyone has questions, just tell your question, and then it would be great if you could repeat the question quickly.
Yeah, sure.
So that the people on the stream also can hear it, because otherwise you have to run around with the microphones, and this is a bit annoying.
Yeah.
Thanks.
How would you draw the graph of the eagerness to adoption for the people who write client-side code?
So it was about this graph, the question.
Like, it's basically, was it worth it, right, for client people?
Yes, I mean, first of all, you have to consider that we are, all of us, we are basically full stack developers, especially at this point. Everybody does a bit of everything at FelFel, especially in our team. So, but I mean, definitely it helped us. Something that it really helped us, and I kind of forgot to put it in our presentation, was kind of generating TypeScript definition directly from our schema. I mean, this was really kind of like mind-blowing for us, especially around the null kind of types and nullability. I mean, this was something that we were really struggling with. So yeah, I mean, as I showed in this graph, like the curve at the moment, like the slope is positive, so everybody's happy. But so, sorry, did I answer your question? Okay.
Please.
Do you know if it's a common experience when you have it? Seems to be scrambling a bit in the beginning, trying things, doing more. Do you know if that's like the case for most people trying?
Okay. So the question, your question was about this, if this is a common, like, and first of all, I don't know if other people experience such thing, but one thing that I know is that we all want to jump to the fun part. because literally all of these issues that I mentioned, they are somewhere in the documentation. Like the documentation of HotChocolate is quite good. It's just that we were too excited and we jumped over a lot of things. And I think that's actually something that probably happens in many companies. So exactly. I mean, as I said, like for us, it was completely it was extremely exciting. I mean, you have to consider that really we were struggling with this kind of how to manage this development cycle between the front enders and the back enders. So yeah, as I said, I don't know about other companies, but I guess it's very probable. Yeah, of course. I mean, that's the fun part, no? Yeah, I think that, I mean, in general, from a personal point of view, I think there are two fun kind of parts in integrating a new piece of technology. The first part is really this kind of like this challenging, frustrating time. And I mean, it's kind of interesting because the project is also a bit smaller. So it happens that, I don't know, some developers just overnight, like you kind of like, you go home and then the next day the code base looks completely different because someone just like was fed up with certain classes or names or whatever, and they just change it. And the project is small enough in the beginning that you can actually tolerate such huge refactoring. I think the second part is when we have a stable structure, as we believe we have right now, and then you start kind of delivering business values and you kind of see that your work is paying off. So I will definitely do it again. So
very nice. So thanks again. Great talk.
Thank you.
I may have to change my talk now a bit. I didn't know that you also do GraphQL data. No, it's fine. I think we will just make a quick break so that we can set up the next talk, and then we'll be back in
I'm sharing my screen with Wir sind wieder live, aber ich habe dein Mikro noch im Moment abgeschaltet.
That's great.
Nein, ich habe noch.
Okay. Right. I think we're more or less all the people. So let's continue with the last talk before we get the final refreshment. It's basically an addition to what you did before. It's also a bit about DataLoader, but it's a little bit different. So I would like to invite you to this journey. Thank you. I'd like to invite you to this journey where we start with a simple server, which has the classic N+1 problem. Then on the way.
Is your mic on?
It is.
Yeah, it is.
Does it work?
Yeah, it works.
Good, fair enough. On the way, we'll learn about batching, and in the end, we will end up with data loaders in places where you might not expect them. So let's begin. What do we work with today? We have this GraphQL server, and it's a really small GraphQL server that has some blog posts, it has some categories, and it has some users. And we just get a message from the UI people, and they say that the server gets really slow when they include the author of the blog posts. The same happens, by the way, when they include the categories. Now, the thing is, we react as we do as good developers, and we first say, that can't be, right? And then we try it out ourselves, and when we go to this query and we run it, you actually see that we're pretty quick. So we're between 5 to 50 milliseconds. As soon as we include the author, like this, then we see that we have 300 milliseconds. So something doesn't seem right. And when we have a look at the tracing that we set up, because that's the easiest way to see what actually happens on the server, then we quickly realize, it seems familiar, right? You quickly realize that this is probably not the best way to fetch the data. So what we do is, for each blog post, we actually make a query to the database, and we fetch the author for this blog post. So this can be optimized. And when we go into the code, well, that doesn't work. Where's my writer window? There we go. We see that we directly call a service method, and this service method makes a database call. So in this case, this doesn't work. Can you hide me, please? Yeah. Thanks. Awesome. Right. So let's have a quick look at how DataLoader actually works, because we did some research, same as you did, and we found out that it makes sense to use DataLoaders for this problem. And a DataLoader is a generic utility to be used as part of your application's data fetching layer to provide a simplified and consistent API over various remote data sources, such as databases or web services via batching and caching. That's exactly the first paragraph that you get when you go to the official DataLoader repository. And this is a lot to take in. So let's break it down a bit. First thing is, DataLoader offers a consistent API, meaning you have only one method on the DataLoader, which is called load or load async HotChocolate, and there you load the data. And this is the same for authors, for users, for posts. The second thing is batching. That's what you talked about before. So we do not want to make, as soon as we request a user, we do not want to make the database call. We actually want to wait until we have more than one user. And the third thing is, and this is something which will be a bit highlighted in this talk, is caching. And this doesn't have to do something with Redis, and it doesn't have to do something with memcache. It's just that when we already have the user fetched in this request with the ID 1, we do not need to fetch it. And we can optimize, for example, mutations by this, by prefetching data or just priming a data loader. We'll see that in a bit. Right, how does a data loader work? In the most basic way is, and it doesn't get really more complicated than that, we just load async, right? We have a user data loader which loads the user by ID. And now we just pass in a user ID and we get a user out. So it's 1-to-1. This we call a batch data loader. There's actually also another way to do data loading, and this is called a group data loader. And what we do here is we fetch one-to-many. So we say, I have this group ID, and I want to have all the users which are in this group. So this is a grouped data loader. And now, a bit on the execution of how this works. I will try to highlight some different things than Behrooz did before. How does this work? We have this simple GraphQL query, and what it does is we select start from post, so we get all the posts from the backend. Now, what we get returned is from the database is this. So we get the content, which requested, and we also get the IDs of the author. So what happens now in the completion of this value of this resolver, the post resolver, we arrive at this stage. So we complete the first item of this list. And now we can immediately resolve content because it's already there. And we have to dispatch author. So what we do is we take this author ID and we batch the author ID. We do not resolve anything, we just wait. And the second thing is when we arrive at the second item, we do the same thing. And in the third item, we already have this ID. We already batched this ID, so we do not have to batch anything. And now we have batched two IDs, and we fetch two IDs from the users table. And this is really powerful. And we want to build this now into the server. So by the way, forgot about this. This also works. So how this works behind the scenes is that in HotChocolate, we just execute as long as we can execute. And when we do not have anything to do, we expect that we now have to dispatch the batches. So we start executing the post resolvers and the author by ID resolvers, and then we do not have any batches. And then these resolvers return the data, and now we can actually do the batching. So we take everything that's dispatched, and we make one round trip to the database. Basically, it's a stack. We wait until there's nothing on the stack, and in this point, we dispatch the resolvers. It's a bit simplified, but it's how it works. Right. So let's go to the code quickly, and let's fix a bug. So we've seen that before. What we do is we just implement quickly a data loader, user by ID, and there we have the batch data loader. Because we want to fetch user by ID, we need to pass in the key, which is GUID in this case, and then we have the user. There we go. Now we implement everything, and we also need access to the data here. So we use the repository. There we go, like this. And now we have this this load batch async method. And what this method does is it gets a list of IDs and it returns a dictionary, or for the JavaScript people, a map. So basically a key value store. So what we do is we fetch all the keys, all the users with the keys from this repository. Get users by ID async. We pass in the keys and the cancellation token. There we go. And now we have to wait that. We basically have to map this back into this map, and we order it by the ID. There we go. And this is the data loader, that everything that we have to do to implement the data loader. And we can already use this data loader. So instead of calling the service here and returning here, we just inject the data loader. And then instead of calling the service method, we call the data loader, and we call it async of the post author ID. There we go. That's it. And now the issue should already be resolved. So when we go back to banana cake pop and we execute this request, first request is always slow because we have to build the schema behind the scenes. But then we see that the requests are actually a lot quicker now. It's a bit small, I'm sorry, but you will see it in the tracing. When we go back and we see that now we actually only have the resolvers here, but we have no database requests. The database requests start at the bottom where we have this execute user by ID data loader batch. Let me make that quicker. I think when I do this, yes. Well, that sucks. There you go. So you see the execute by user by ID DataLoader batch. And we batch all the users together. And the nice thing about this is that when we have a look at what we actually executed, we only have fetched 4 users. So there were 30 posts, but we only have the posts written by 30 authors, by 4 authors. So we only need to fetch 4 users. We do not need to have fetched 30 for this reason, because we already know which IDs we need. Same thing goes for the categories. There we have a many-to-many data loader. We can also use the batch data loader for this, but we'll do it a bit differently because, you know, as Behrooz said before, this is a lot of boilerplate code, and the only thing that we actually need is this batch method, right? So there's a bit of magic behind the scenes, which I'll explain in a bit. But what you can do is you can just define a public static async task where you return a dictionary. So basically, that's I was wrong. That's the same method that we have below, categories by ID. And here we get a list of IDs. And we also, to fetch the thing, we need a service. And 1 second, service. There we go. We need the category repository, like this. And let's also use a cancellation token so that we have a clean cancellation. And now we can fetch the categories from this repository. There we go. Get categories by IDs, keys, cancellation token, done. Like this. So this is a batch method. It's public and it's static. It's not protected and inside of a data loader, but this is a batch method. So what we can do is we can just annotate this with data loader. And what this does is, behind the scenes, a source generator picks this method up and generates the whole boilerplate code for us. The only thing that you have to do is you have to reference HotChocolate types analyzers in your project, and then this works. And then also this works, that it automatically registers everything, because I would actually have to register this data loader on the schema, but now I do not have to. Right, so what we can do is we can go here, and we now have this categories by ID data loader. There we go. And we can just use the data loader now to return the categories. Just like this. And we're all done. And what this source generator does behind the scenes, by the way, is this is the code that it generates. It's actual C# code, and it's all the annoying boilerplate code that you do not really need. Right? Great. So we leveled up. We now officially beaten the N+1 problem, and we can now go back to the UI people and say our server is faster than ever, which is good. But so maybe you ask yourself now, what's beyond N+1? And let's have a look at the architecture and let's see what we actually did. So I'm not a huge fan of, you know, the .NET way of doing clean architecture and have 5 layers and whatever. But I still like to have my domain logic separated from the GraphQL layer, like Behrooz said before, right? So what we had before we introduced data loaders is that we have this GraphQL layer, which accesses the domain logic, the services, and then it accesses the data access, the repository. And what we have now is that via the data loaders, we access the data access layer directly from the GraphQL layer. So while this doesn't look good on this slide, it's actually even worse when we go into the code. So when we go into the code, again, there we go, and we have a look at this method. So what we did before was we had this user service, and we actually called getUsersById async on this user service. And when you have a look what this service actually does, we see that, you know, it's not that this just returns the users. there's actually domain logic on it. So that means if the user is private, then we should not return the user. But when we directly use the data loader, there's no check on this. So we just return all the users now. So there's no check for this. So that's bad. Same thing, by the way, goes with node resolvers. Seen this at least 5 times. If you have a node resolvers and you need an ID and return the value, the easiest thing and the most obvious thing to do is data loader. Awesome. So you plug in a data loader, and now you have a nodes field where you can fetch all the IDs, and you do not have any domain check or authorization on it. Right. So how can we fix this? What we can do is we can basically duplicate this logic. So we can copy this and then have it into the resolver and then do the check in the resolver. But I mean, this smells, because then we have the domain logics. First of all, we have it duplicated, which is bad. And second of all, we have it in the wrong layer. We have it on the GraphQL API. And even Facebook does it this way. GraphQL should be a small layer around your domain logic. It should not be your domain logic. There are valid approaches of doing this. But in this case, it shouldn't be that way. The second option is, what we could do is we could directly use the services in the data loaders. But again, we would solve the problem of having the domain logic separated. But if you have a look at what this method actually does, is it gets a user by ID. And if we now need to use this in the data loader, there's no user by ID method. There's a users by ID method. So still, we would have to duplicate this. And we can now make methods, and then, we can make it complicated. But the nice thing about this method is it's super easy. And if you write your methods like this, everyone understands it. So it goes in here, and it's basically an easy way to follow through how your domain layer works. So there's a third option. And some may say it's a bit controversial, but I like it. What we can do is we can directly use the data loader in the domain logic. And when we do this, we have the benefits of having a clean domain layer, and we have the benefits of batching. Because now get users by ID is called 30 times in this request, but it still waits here until all the users are dispatched. And then we do this quick check. So we have the domain logic, the domain validation, and we still have the big plus of having batching functionality, right? And this works great, but it's always, as it is in life, it's a bit of a trade-off, what you want to do and what you do not want to do. Because, let's go quickly into this. The caching that you get is request scoped, but what you lose is you lose optimized fetching, because you're now restricted by what, let's just go quickly through this. So you have this consistent API of load async. You always fetch by ID or by name or whatever, but you need data loaders for it. So if there is no user by name data loader, you will not be able to fetch by name. So you have this consistent API, but the API is not expressive because you just have load async. And then when you have repositories in your domain layer, you have rich API possibilities. You can say, rename or whatever, but you cannot do this with a data loader because there's only one method on it. And then the last thing is service method now have to be scoped because you inject the data loader into it. One nice side effect, though, again, I don't know why this doesn't work with the screen. Anyway, one nice side effect, though, if you really go down this road, is that this also works for mutations. So now I have to think. I think it's in this one. In this create post async method, we call directly the category repository to fetch the categories that we pass in. So when you create the post in a category, and then you have to fetch them to see if they exist, because if they not exist, then we throw it, right? So what we can do is we can also use the data loader here. By ID data loader. There you go. And same thing again. Nice and clean. And now we have two side effects which are really nice. One is this batch, which in a mutation doesn't really matter anyway because they're executed in sync. But what it does is it enriches the cache. So we have these categories already in the DataLoader cache. So when we go to this mutation, where we actually create a post, and we pass in this category ID, let me see a nice side effect. There we go. So I execute this mutation. When we have a look at what happened, is that, 1 second, I have to show you actually first. We fetch categories here, we pass in the categories, which we validate in this resolver, and then we have the categories returned here. So, you know, this is the same information that we have to fetch from the database. And you even see this is the same ID, 33E, 33E, whatever, you know, that's the same thing. And when we have a look at how this looks in tracing, it's actually quite nice that when we execute the create posts resolver, the mutation, we first execute the DataLoader patch, and then we add the post to, this is the second database call, to add the post, and then we have this third resolver, the categories resolver. And this doesn't have to be, doesn't need to make another database call, because we already fetched it, so it's already in the cache. That's the caching part of the DataLoader. That's quite beneficial, because you can start playing with this. There is, for example, also the possibility for you to, they call it priming data loaders. When you go to this method, it's also a service method, we see that we fetch the top 5 categories, and we cannot use the data loaders to fetch these categories because it's, you know, rich API. We want to have the 5 top categories. We cannot fetch by ID. But what we can do is we can fetch them, and then we can use the data loader, and we can basically set the values on the data loader. So that's called priming. We take the data loader, and then we know we have categories, and we say, yo, you know, this ID is this value. And another thing that sometimes is useful is, that's wrong. Sometimes you also have to remove stuff from data loaders. So here, for example, we rename a user, and we do not get the user back, so we cannot prime the data loader. So now we can just say, you know what, user by ID data loader, remove this user because it's now different. So we do not have the wrong data in the tree. Great. So let's have a look at PowerPoint presentation if there's anything left. Q&A. Do you have any questions? Please.
Yeah, so for me, it's quite new, the data loader concept, or I know it, didn't really use it. So would you use it as well for, like, you talked a lot about like having a per request cache, but also if you want to cache it for longer or have it like connected to a distributed cache, or would that be?
So generally, you can connect the data loader to a distributed cache, but you should not use the data loader as this. So you should still have this request scope. So you can have your caching layer that uses Redis, Memcache, whatever you like. And when you execute the data loader, you basically ask the cache if this is already in cache, otherwise add it to the cache. So you still have this request scoped caching. So I would really not connect it with some kind of distributed cache. The caching layer is behind it, you know. There is the concept of global data loaders, where you basically share an instance, so they're not scoped. But it's difficult. It's difficult because sometimes you have to invalidate data, and you know there's this joke that we all know, right? And it's hard to know when you have to invalidate data. Any other questions? Yes, please.
Yeah, but how have you structured this? I mean, the way I understood it, the repositories have no access to data loaders, but the data loaders are more like type specific or data specific. So if you want to separate them in objects to avoid circular references, how would you do that, like active data loaders in the center?
Yes, so the question is, how do you structure your project that you not have circular dependencies? If we go back to this layer, and we are exploring a few things to this slide, we're exploring a few things here. Already with normal data loaders, what you would do is you would have your domain logic, and the domain logic basically has a reference to your abstractions. And in the abstractions, you would have the data loader reference. You know, there is, for example, there is iDataLoader that you could use. And the iDataLoader, basically, this data loader loads the user by ID. As soon as you have named data loaders, you know, you want to also load the user by name or something, or by category or whatever, then it gets a bit more difficult, you know. One thing is to just include this reference, and the other thing is to actually have interfaces. You know, you have in the domain logic, you have interfaces. So when you go to the, I think we generate them, but I'm not sure. There we go. Yes, so you see, we have this iCategories by ID data loader. And this interface could live in the abstractions. And you do not even need this reference. You could just have the load async method on it. And then your domain logic just needs to know what data loaders exist. And you plug it all together on the API layer. You know, you take then the service collection, you register your domain services, you register your data services, and as soon as you do this, everything goes together, and depends injection works at its best, I guess. There are, though, a few things that we are exploring here, because there is still, if you go down this route, and we've done this in projects, there are still limitations with this. For example, especially when we look at the, that's also why I said it's a trade-off, as everything in life, right? If we go to the post service, there we go. Here we fetch categories to check if the categories are.
We don't see that.
Why?
Again.
Is that me?
Yeah, that's you.
No, that's your screen, not my screen.
I didn't touch anything.
Because I don't know. I do not have this fancy memory indicator on the top right. Anyway, so what we do in this method is we fetch the categories, right? And when you go down this road, you sometimes have more complex logic in the domain logic. So for example, when you have to load, you need to know the group of, you need to know, when you want to add someone to the group, you need to fetch the group, but you also need to fetch the user and whatever. So it could be that you have 3 data loader calls before you actually start with the domain logic. And we're playing around with this, so there's nothing like final yet. But what we are thinking about is to do something like, in EF Core, this would be like really handy, that you can say one data loader that you actually also want to, or it's actually more or less a try include. You actually also want to include the posts. And then this data loader would also do the include, and then the data would be fetched in one go. And if it's already fetched, then it just doesn't care and it just doesn't fetch it. And then you have a second data loader here, where you do the post by ID data loader, whatever. And when you then execute this data loader, it actually observes the other data loader. So that means when you have the easiest example for this, and this happens really fast, and I'm pretty sure you have the same thing. You have a user by ID data loader, and you have a user by name data loader. Well, if I now fetch a user by ID and then reuse this user or want to reuse it, then I need to somehow connect these. They need to share the same cache, right? Because otherwise, you know, we fetch it twice just because once we need the ID and once we fetch it over the name. So that's also something. And it could be, to go back to your question, I really hate this, that there's actually another layer. One layer that is aware of the data layer, and it's also aware of that it's executing in the GraphQL context. Because then you can do fancy stuff. Then you could do, for example, protections in a data loader, which is something which is requested often, but it's really hard to do. And with this additional layer, this would be possible. Sorry for going on so long. Yes, please.
The assumption here is that they're using HotChocolate. But basically the service that you can we use the service that we inject the data loader inside outside like in the REST outside
So your question is if this is only HotChocolate specific. I wouldn't say so. So DataLoader works so well with GraphQL because GraphQL enables it to have it nicely dispatch the DataLoader. Because you have this execution tree, and you know when you do not have anything to do, and there is stuff to be dispatch, then just dispatch it, because that will probably resolve the deadlock, right? So it works in controllers, and I've used it also in controllers. When you have a GraphQL API, and then you have some controllers that you still need, because REST sometimes is just the better way to do it for some things, then you can use the same data loaders there, because your domain logic doesn't know that there's GraphQL. Your domain logic only knows that there's a data loader. It's just a bit, it's not so nice how it batches, because now you just load by ID. When you load the user by ID, you just immediately dispatch. So you just do the auto dispatching, because there is nothing that tells the data loader that it should dispatch. Because in the other way, the execution engine knows when it should dispatch, and it tells the data loader, do the request now. But when you do it in a REST controller, there's no one telling that. So you have to dispatch immediately. You can use it, but it's a trade-off.
I was wondering if you can actually show them that the part of your injected services, like in your code, the one, for example, that you're removing the user from the cache.
Yes.
Show the constructor of the service?
Yes, I can. Let's show this one. Here I just inject the categories by ID data loader directly into it. You can also use the interface. I mean, this is now just, let's make it more .NET for the people, We have interfaces for everything. So now we also have an interface for this. This is one way of doing it. You can also have it more abstract when you go to the user management. User management service. There you go. You can also inject iData loader. But here, you really have no idea what this means. It could be the ID, it could be the author ID. Who knows? Question answer?
Yeah, I would like to also see the stuff. I mean, in the sense that I want to really see how this data loader is injected.
You mean on the right? Let's have a look.
Well, library. I mean, how basically you put this data loader?
So basically, we register services, and then we add the types and the data loads. This, by the way, what the package does for you. The HotChocolate types analyzers. This is all generated. So it picks up all your extensions.